Hi, my name is Matthias and my student number is 24314. I'm in group number 5 where we are creating the Easy Basket. My role in this project is the software developer. Our project is about making a smart laundry basket that automatically reads when the laundry basket is full and sends the signal onto a platform which we think healthcare organizations can use in order to better plan their daily activities and thereby reduce the amount of time wasted every day on bad planning. With this project, we are aiming to measure if a laundry basket is full. The meaning behind this is that some healthcare workers sometimes have planned for doing laundry at an elder person's home, but when they arrive, there's no laundry to do, and they have therefore wasted their time going to the elder's home. Therefore, we want to measure when the laundry basket is full and send the signal to a platform the healthcare workers can use to monitor the laundry. Right now, the constraints in our project are battery power and also the limit of 2 messages per day in order to reduce cost. This is according to a representative at Sigfox, where the cost is influenced by the number of messages we send each day. We haven't tested for how long the device can operate, but according to Sigfox, it should be at least for 6 months. Therefore, we also expect that this device should be serviced approximately every 6 months, or maybe later as we plan to use a bigger 9-volt battery. For the components we used is of course the MKR Fox Arduino 1200 with a Sigfox modem, some batteries and the HCCR04 ultrasonic sensor. Our success criteria was to send a signal to Sigfox that measures reliably whether the laundry basket was full or not. By creating the cutoff line, which I will show in a minute, we can measure when clothes hit this line and thereby if the laundry basket is full or not. Here we'll go through how we're using the Arduino and the code we have made. First of all, we have included the Sigfox library, and then we have defined which pins on the Arduino we are using. These are used for the HCSR04 sensor, and then we have a boolean full or not, which is just to show true or false whether the laundry basket is full or not. Then we have these variables, which we're using to calculate the distance with our sensor. Then we have the void setup, which just set up the Sigfox and then also has a debug. Then we have our loop where we're doing our math. Our height defines the width of the laundry basket and is set to centimeters. This can be changed so that if our width of the laundry basket is more than 50 or less, then we can just change it in our code. Then we have all of the calculations for the sensor, which is made here, and it's based on sound. So we have the calculations based on how long it takes and then back again. And then we can print out just to show whether this works or not in our Arduino. The distance and then with the distance. Further on, we can see we're using these boolean, and we're setting the boolean to true or false based on if the distance is less than the height or more than the height. And then finally, we're sending all of this to Sigfox. We're just starting a packet and then we're writing the full or not, which then sends a value to Sigfox with a 1 or a 0. And then we're ending the packet. At last, we're having a delay to make sure we're not sending thousands of messages each second. So our delay right now is 5 seconds. This makes it easier to view in the Sigfox editor. Okay, so what we have here is our Arduino with our HCSR04 sensor and then the antenna included for the Sigfox. And then we have some batteries that we don't need right now because we're connected via USB to the computer, as you can see as well. Right now I'm showing you both the Arduino editor and the Sigfox backend as well. So we can see now that, if you can see my mouse, that the laundry basket is empty and the distance is 179 centimeters. That is more than the 50 centimeters that we have shown in the code. That also means that it will show full or not 0, as our boolean was 0 when it's empty. And then if we create an obstacle and turn this around to face the table, then it should send to the Sigfox network that it's full or not 1 in a second. Yes, there it is. And also the distance is only 6 centimeters, so the sensor is working on at least wood. So that's good. So what have we learned from this experiment? I have learned that just because a sensor can measure a distance, it doesn't mean that it can measure a distance on everything. This includes our sensor that's not really able to measure distance on clothes, but it can measure distance on a wall or any hard surface. This means that for our purpose, the sensor didn't really work. And therefore, having a knowledge on the sensors and their use cases would have been great to begin with. We had to figure this out for ourselves, and testing this, we found that it wasn't really that useful. Furthermore, our sensor is using 5 volts, which cannot be provided by the 2 AA batteries. Therefore, we have to incorporate a 9-volt battery with an voltage regulator to use through the Arduino. This is also something that we could have known if we had some sort of expertise in it, but it has been a fun learning process, and at least we got something to work with the Sigfox. So yeah.